Hello my dear friends, welcome to Internet Electronics channel, and today we have Ikea wireless charger. I don't know what's the proper name and how to pronounce it, but it says Rallen or Rallen. I have no idea, but let's say like this. So this one, Qi Charger, output inductive, only 5 watts, but it input is 19 volts, 10 watts. So yeah, like 5 watt getting dispersed somewhere in the air. So found this one in thrift store and it's working, already tested. And it is working. And obviously, take a look at this. It's another weird connector and it is center positive. Yeah, 19 volt. So our goal today is to, by the way, this charger, look how many different kind of standards here: Intertech, ITE, SLV, like CE, and you name it. And here like safety mark, EAC. So this guy, even some kind of Korean stuff here. Wow. So this guy is certified to the brim. Okay, let's take a look at this. It has some kind of rubber. Oh, does it come apart? Oh, this is, look at that. Okay, so I think this is the kind of charger that can be embedded in the furniture, and looks like it would be relatively easy to take apart. Well, let's just do it. That's probably some little light here that is operational, so because it has only like 1, 2, 3, 4 latches here. So can I just, yeah, looks like it's just by, I would need 2 of these things. One gonna be inserted here, another gonna be pressing right here, just to get it to open or something. It won't be that easy. Not cooperating. Okay, maybe this is just like that. Just freaking force it. Let's just force it. Just force it. Alright, that was relatively easy. Here we are. Okay. What's that? What is that? Okay, here's the coil and the ferrite. So this is the coil. So it looks like it's like a two layers. One, and then it goes into another, and so it's only 2 wires. So there we have ferrite kind of. It's not the core. It's not the core per se, but it's like external core. Yeah. Obviously, nothing gonna be on this side of the board. No. Yeah, the ferrite, this core is actually glued to it. And here we have it's 2015 vintage. It's not that new, really. That's pretty cool. We have this chip. Is this like a serial communication? What the hell is this? What is that? And it's like broken. Like, look at this. It's like, I don't know if you see it. It's like all crooked. Like, what's going on? Yeah, there's resistors right here, which are not populated. Oh, I see. Now I understand. Okay. Take a look at this. So what's happening here, I believe this thing can be cascaded, because look, exactly the same footprint, V out, and it's connected to this guy. So potentially these things can be like cascaded, because very similar, layout of this connector and this connector, and this, for example, is connected. Yeah, So I assume this and that is essentially to chain them. That's very interesting. Technically, you can daisy chain this guy. So I'll obviously gonna connect it to the power and gonna just try to poke around here. I was kind of hoping that would be a serial connector or something to this extent, but no, I don't believe so. Especially by seeing this big ass capacitor right here across. Yeah. So I don't know why there's a missing. Is it missing or? Let me zoom in a little bit here. Okay, so this probably and this is essentially the same. It's to daisy chain them, I believe. I'm gonna measure, obviously. We have this microcontroller of a sort, and there is another chip. So there are not that many active components. A few inductors here. So this is clearly an inductor. Whole bunch of capacitors, and very interesting something right here. Really hard to. It's two resistors. Never mind. There is another transistor. Oh no, it's another chip of a sort. Just right here. I believe this is LED, the one we saw right here. So there is a little pokey hole here, like with some kind of light pipe. There is a whole bunch of capacitors, but I believe those capacitors are on a V out or V in, let's say. Yeah. So this is and filtering capacitors of a sort, on this rail. And these capacitors are clearly connected to this output coil. So yeah. So here probably it forms some kind of filter. So we have to understand what is that. It'd be nice to find the schematic of this. By the way, this thing is from 2015, 0115, 1015. So this is a relatively old design. It's like almost 8 years old. So yeah, that's pretty cool. That's pretty cool. I'm curious what can we do with these capacitors and what kind of chip is this? Let me kind of look under. Yeah, guys, like, and this is serious business, but I still don't have any kind of microscope, to do this magnification. This is insane. I have to do something about it. All right, so I did some investigation and I figured out the following things. So the most obviously interesting thing is the core of this operation. This guy is ITDP9030. It's a single chip Qi wireless power transmitter, and never mind, IDT by Renaissance, and it's obsolete in 2017. So this guy is already obsolete. Keep that in mind. Really hard to find any why it's really hard, because looks like it's register. You have to register on Renaissance website in order to get any data sheets on this chip. So, but also I found very interesting information on a evaluation module with this chip from Renaissance on Moser website. Apparently, it tells a lot of very interesting information how this thing works. I'm gonna share it on my website, where I'm gonna share. I usually share the close-up photos and some technical documentation of this wireless charger. And looks like this wireless charger in some kind of proprietary mode can go up to 7.5 watts. Not just 5 watts. So this is the guy, and clearly, so this is the transmit antenna. All right, so this is some capacitors which are probably create resonance circuit, because the antenna capacitor obviously can LC, and here those big two traces, they're clearly coming into this controller. So this guy is like has shitload of stuff. It has controller, it has interface, it has microcontroller inside, it has like a H bridge. Probably it runs, and I'm curious to see at what kind of voltage this thing runs. So yeah, sorry, not H bridge, what I'm talking about. Yeah, H bridge inverter. So yeah, there is a lot of information in this particular evaluation module PDF. So yeah, it was very interesting to read. Also, it explains how to configure it, explains how it works, yada yada. And there's also even proprietary software you can actually get in order to program this guy, and also program this. And this is EEPROM, which marked as A71 8107S. This is essentially what it says here. The problem is I couldn't find anything on this guy. Like, I have no bloody idea what is this. Okay, we have a little LED here, and clearly this is EEPROM because, I mean, it's not clearly, but it is sort of connected straight to the microcontroller, so it is EEPROM or thereabout. But I'm telling you, this is EEPROM because this doesn't have EEPROM on it. So this little guy is highly likely, couldn't find any information on it. It says R3F. So this is some sort of LDO, and I believe this is 3.3 or 3.5 or 3 volt LDO for this microcontroller because it needs 19 volt to drive the circuit, which is coming from here, and it needs I mean, it's kind of, I don't know, it could have just have internal voltage regulator, but yeah, I don't know. Oh, yeah, even if this guy, it has something internal, this guy won't. So, yeah, this is probably 3 or 3.3 volt voltage regulator. We can again double check that. So this guy is connected, and let's poke around with some voltages here. Okay, we have multimeter handy. It's glary again, which I hate, but okay, so let's get, so this is probably our ground. Also, let's double check what's going on here. What the hell? Essentially, this I cannot understand. There is a connector here that says V out, which is clearly is V in. And here is the connector that says V in, but it's not nothing connected to it. It's insane. And looks like this guy is clearly connected in parallel. So this is essentially to daisy chain. Why would you daisy chain this guy? I have no idea, but here we are. So it's kind of hilarious that this is not connected here. I just can't wrap my mind, unless someone broke this connector, right? Attention here, broke this connector right here, poking around while poking around in it, and decided to just resolder it like this. Could be, could be. So essentially that was never populated. It was connector here. Someone just busted this thing, rip it off or something. Couldn't find replacement connector, just like Anyway, so let's keep the ground as a ground and poke around this voltage regulator. This is something weird. This is even weirder. I don't have 3.3 volt. That's weird. Okay, 5 volt regulator. Okay, we have 5 volt regulator. So clearly it needed to run EEPROM. Okay, so that's good. Let's let me switch to AC. I don't know, and see what we're gonna have here. Well, it measures 5 volt AC. Cool. Okay, I have another very interesting experiment to do. Let's just do it. I'm wondering, or I wonder, how much current this thing can pass, how much energy this thing can pass through. Okay, how would you measure that? Of course, you can measure, like, capture the field and somehow measure the energy transfer, but take a look what I have. Ta-da! This is awesome thing I got ages ago for some other project. Actually, I have many of them. For some other project, all right. So and this is never actually. I didn't finish the project, so I end up using these guys for something else. So what are these? So these are the wireless chargers for the phones which don't have wireless chargers. So the only downside, obviously, that this occupies the slot. So if you plug it into your phone with wireless, put it under your lead or something, like how it says here, right? You're gonna use your micro USB connector. It's just, that's it. So, but we have DROC. We have this guy. Let's do this and see what's gonna happen. Oh wow, it kicked in. So, oh, it's actually, look at this sign here. It's a Qi charging thingy. So yeah, it actually runs at 5 volt. Oops, that's finicky. So I have to really position it nicely. No, really. 5 volt right now. 5 volt. Okay. Yeah, I don't know why it's doing that. Is bad connection somewhere? Okay, let's just crank it up. All right, 4.665 volts at almost 1 amp. This is 4.3 watts. It's not 5 watts per se. So let's try another guy. I'm not sure, maybe it's another guy would be better. It's very careful with these little dinky connectors. Okay, let's try this guy. Never played with them, so please excuse my... Alright. Right away, oh, it's getting different voltage, smaller current. Let's crank it up. We are at 4 watts. Oh wow, this is doing better. 4.7 watts. It cannot sustain more than 4.7. Let's revert. 4.5, 4.4. Yeah, it's doing 4.4. Ah, maybe not. Let's go back again. 4 watts for sure. Okay, very cool. So this thing is sort of ballpark in 4-5 watts. Obviously, the 4-5 watts range. Obviously, you cannot trust these dinky guys because this is like, yeah, it's an experiment which actually never come to fruition. But I'd like to keep those around, for example, for that. So you see, that's a good test. It actually shows this thing is operational, but it's not it. Check what I prepared here. Oh shoot, I need the oscilloscope in the frame as well. Okay, so I have this broken wireless charger. It doesn't work, at least doesn't work with the modern phones. Probably it supports some kind of weird ass protocol, which is, I think I had the review of this guy up in this corner, so please take a look. It has broken, how do you call it, ferrite whatever plate, let's call it ferrite plate. And what I need right here, I can just desolder it. What I need here just a coil, right? I'm just using coil, so I connect the oscilloscope right in here. Okay. Obviously I could have just connected the oscilloscope straight right here, right? It's gonna be just but when I'm gonna be doing that, you're gonna see something more than just like a signal, because without any kind of object here, that thing gonna behave differently. So let's just try to place. Oh, that would be hard. Alright guys, I have this broken Qi Charger. I don't know if it's even Qi Charger, some kind of charger I bought in dollar store and it didn't work. So I can use it as a receiver coil. Let's see what we can receive. So it connected to my oscilloscope. And we have, it's actually, we have divider at 10x, because when I tried it, voltage was actually pretty high. So yeah, I have it at 10. Okay, let's do 1 volt. Okay, so let's just see what kind of communication or something we're gonna see here. We have something going on right here. What kind of frequencies, I'm curious. Let me change the trigger. Oh wow. Okay, here we are. Okay, let's remove it. Yeah, looks like we have a different burst of the signal. So technically, so from what I know how Qi Charger works, when you bring it always sends the ping of a sword, okay? So when you bring a device which is actually capable of receiving something, they'll talk to each other, and they start charging, okay? When you bring, like, for example, I don't know, a screwdriver, it'll be a different story, okay? So the transmitter coil or transmitter device is capable of understanding what's going on. So let's see what kind of signal we're gonna get when there is nothing. There is no any kind of object right here. So signal is a wee bit different, obviously. But that could be because we have different capacitance on those leads and things like that. So it can actually cause, and clearly pinging. And frequency is, I don't know, 170 kilohertz, which is about right, because Qi chargers can communicate, or actually can charge from 100 to almost 205 kilohertz, and they capable of changing the frequency to, you know, figure out the best frequency for current situation. All right. So yeah, Well, let me get this guy and see. This is like legit guy. Let's see what's gonna happen when I plug this in here. Alright, so something definitely has changed. Let's see what kind of signal we have. We have consistent 205 kilohertz. Very nice. And we are, because this 10x attenuation, it's about 24 volt peak to peak. Why it's 400 millivolt peak to peak? What's going on? That's weird. 40 millivolt peak to peak and 2.4 volt and minus 800 millivolt is maximum and minimum. That's weird, but RMS is almost 1 volt, so it's a bit confusing what is this guy is measuring here. But let me actually grab this guy and see the voltage. Oh no, forget it. This won't be capable of 200 kilohertz. Yeah, sorry. Whoa, okay. Oh, you see it changing? Wow, it's figuring out things as it goes. Let me put the trigger in the center. Yeah, clearly it's doing some kind of business here. Let me, oh my god, this is again complicated. I don't have anything to load it with. So I need to connect like something to this little thingy. Okay, let me get the drock and see. Okay, here I have the drock is attached to the, I don't know why it's tripping all constantly, but let's see what do we have on the oscilloscope when there is some kind of load. Oh wow, clearly there is something going on here which correlates with the load of drock. I don't know why. Is it better? Unless this guy detects too lowest. Let's do half an amp. I just crank the drock to half an amp. No, it's still throbbing. It's a half an amp, how half an amp look like. You see what's happened? Actually, frequency dropped from 205 to 150. Wow, that's interesting. Damn, how to connect all this? Okay, so I used another wireless charger, and this guy seems to be doing better. So yeah, probably that one is a bit worse. So let me reduce the current. So increase the current. Look at this. So amplitude is much higher and the frequency is lower. No, it's actually frequency almost not changing. So it negotiated 140 kilohertz. Now it's 140. Before it was like 100. Okay, now it's throbbing. Looks like if its current is too low, it just goes. I don't see really how much. What's the current? What? It's 3.4 volt, 1.5 amp. Cool, crazy. This thing is still working. I think this is gonna enter some kind of protection thing or what. It's just still consuming. So this is how it looked like. It's now it's not even negotiating. It's just plainly producing power. So does electromagnetic coupling from one equiplanar coil to another. So you know, guys, I will promise you that I'm gonna do proper video about how Qi charging works, because now for me this is relatively new. I don't want to claim I'm an expert here. I'm gonna do my research, I'm gonna do investigation, I'm gonna explain you how this stuff works. But so far so good. We see that it actually works and how the yeah. Wow, that's really crazy. Okay. Yeah, looks like if current is too low, it's just gonna be throbbing. Yeah, now it's working, and it's at... Yeah, this guy is going bonkers. It's interesting, it has to have some kind of current, otherwise it just... Right. Okay, I'm not gonna kill... I don't wanna kill this guy, I don't wanna kill any of these guys. So it looks like this one is... Oh wow, it's warm! Holy smokes, this thing is warm! Ha! Okay, so we have to take this in account as well. Anyways, so this thing can do 5 volt 1 amp, so which is like 5 watts. So this all sort of compatible, and they are working. This is amazing. I think I'm gonna wrap up at this moment because... Oh, how about this? Wait. So now it's time to do some shenanigans. Okay, so as you see, we kind of chain the coils. Okay, and now let's use the phone, which supposedly has the wireless charger. No way, it's charging! It does! No, not anymore. But it tried. It did try. So, yeah, you see this the blue is blinking, so it was working. What the heck? I thought this is busted. No, it's actually working. So, okay, gonna keep this around. But this is junk, I'm telling you. First of all, it has this broken ferrite plate. I don't know how else I gonna call it. Oh, look at this. It's actually ripped off. There was a glue underneath and it was glued like this. Anyways, okay, I have to glue it myself. I glued it before. Actually, it's not gonna slide around because of this rubber thing. So yeah, should be fine, should be fine. Let me take a last test. Let me take a pixel here and just like plop it in. Are you even working this pixel? It does, okay. Yes, it's charging. Charging wirelessly and probably slowly, okay. So yeah, just double checking, it does work with pixel. Okay guys, I think this is gonna be it. It's just more like a like an exploratory video on wireless chargers. I have some videos of wireless chargers. Before I didn't really dive deep, and I still didn't really dive deep too much in order to understand how this cheap charging works. But I think I'm definitely gonna make a video explaining how specifically Qi charging works. I'll try to capture some stylogram here and maybe share with you. Also try to find some very interesting... Oh, it's this coil is actually warm too. Get some more interesting information. Maybe there are some kind of protocol specs somewhere in wireless charging consortium. Maybe we can, or what, I don't know the name of the body not governing, but the body who developed actually wireless charging. I need to learn all that, but I'm definitely gonna make a video and share this information because I'm really interested in wireless charging. I'm actually using one of the wireless chargers like this one in this video pretty much on daily basis, and it still works since who knows when. So that's pretty much gonna be it. Oh, I wish I have a proper place for this whole oscilloscope crap and stuff. All right, so this is pretty cool. This is pretty cool. Thank you, IKEA, for a chance, and Valley Village, for a chance to play around with... What's the name of this thing? Ikea Rallen or Rallen, whatever name of it. So that's very old discontinued wireless charger from Ikea, which still works because all of the modern phones still support Qi charging, probably just a newer generation of it. So guys, that's gonna be it for now. Thank you for watching. See you next time. Stay safe and ciao.